Hi, welcome back to Discovering Patterns in the Microbiome. This is a brief tutorial on using the UNIX command line and Git. This video is optional. It's just intended for those who have no command line experience. I've given you a few basic UNIX commands that you'll be using in this course. I'm not going to list every single one of them. There are lots of great tutorials online. But you can go back to this for a reference if you want. One thing I'll point out is I like to use Emacs for editing files. There's a big debate in the computing community between people who use Emacs and people who use another editor called VI. It doesn't matter what you use, but this is the one I'm familiar with. And so let's do a little demo of these commands here. And I'm going to go over to the command line. So if you're on a Mac, you can get this by opening the terminal. If you're on a Windows machine and you want to connect to another computer, you can use PuTTY, a program called PuTTY. And here I'm actually logged into a machine at MSI, the Minnesota Supercomputing Institute. So the commands I want to show you are very simple ones. If I want to move to my home directory, there's a shortcut for that. It's the tilde. And I would use this command cd for change directory. I'm already in the home directory, so nothing happens. And I would use the command ls for listing the contents of the directory. And so that shows you all the files that are in that directory. Now, what I want to do is make a directory. So I'd use makedir for the class. Makedir mice 8992. And if you don't already have a directory on your personal computer, then you should do this too. So make that directory. I'm going to move into it. So that's cd. List the contents. Of course, it's empty. I just created it. Now, there's actually an online code repository that's going to contain lots of pieces of code and various data sets that we're going to use in the class. And this is stored on a website called GitHub. This is a standard practice in software engineering to keep consistent versions of your software always updated somewhere. Anytime you make a change to your software, you should upload it to the repository and put a little comment saying what the change was. That way, if you make a mistake, you can always roll back and people can always tell who's doing what. So this is the course repository. There's not a whole lot in it right now, but you'll see it has a data folder. The link for downloading this through the terminal is here. So you'd copy that link and you use git on the command line. So if you're using your own computer, you will have to install git. If you're using the Minnesota Supercomputing Institute, git will already be there. You say git clone and then the course name, and then whatever name you want that folder to have. So I'm going to call it repo. So let's run that, cloning into repo, blah, blah, blah. Downloads all the stuff. Here we are. So let's go into that repo and see what's there. cd repo. Just a few files. Let's look in the data folder. So there's this folder called Global Gut. These are some data files from a study that I was involved in a couple of years ago, led by Tanya Yatsunenko. And we're going to be using these for lots of examples during the class. So let's go into that folder. And we see here there's a metadata file or mapping file. There's a biome formatted OTU table. And here's a small number of input sequences for that data set. I'll show you a couple of commands you can use to edit that data. So if you want to look at the top of a file, the first few lines, you use the head command. So let's see what that looks like. So there's the top of the sequence file. You can say how many sequences you want, or lines you want. So if I say -n2, let's try that again. I get that. And here you can see this is in chime format. We have the sample ID, underscore, and then a sequence identifier. And then the next line is the actual sequence. You can also run the output through other programs. So I could say call head on the mapping file. And that's a little hard to read, but I could run that through the cut program. Like this. And what happens here is this is called a pipe. It's the little vertical bar. This takes the output from one command and feeds it into the next command. So when I do this, I'm sending the first 10 lines of map into the cut command, and cut just cuts out certain columns of your file. And I say -f for fields, and I want fields 1, let's do 1 to 3. Oops. There we go. So that has extracted just the first 3 columns from the mapping file. Now, another interesting thing you can do is, I'm going to move up a directory. So ... means the parent directory. If you want to update this repository, you use the get command again, and you use the word or the command pull. So you say get pull, and that goes to the central repository, sees if there's anything to update, and downloads it. You can also check the status of your local repository to see if there's anything new there or anything that's in the central repository that you don't have. A couple other simple things you can do here. If I want to edit a file, let's edit this file. I'm going to call it temp.txt. I'll use Emacs, put something in it. Let's just say hello world. Now, to save a file, it's Control-X, Control-S. To exit from Emacs, Control-X, Control-C. And now there's a new file here. It's essential that you be able to open up text files and edit them, because you'll have to do this from time to time. So I can move files around. Let's move temp.txt up to the parent directory with mv. I can move it back, and I can remove it. Note that you should be very careful with the rm commands. It's not going to warn you about deleting things. So if you say rm star, star means everything. So it's just going to remove everything in the directory. We're back in the global gut data folder, and I want to show you word count. So WC tells you how many lines, how many words, and how many characters are in a file. It's a little faster if you just want to know the number of lines. Just type -L and it gives you the number of lines. So you can use this to figure out how big things are, how many sequences are in a file. Of course, this is a FASTA file, so 200,000 doesn't mean that there are 200,000 sequences, because every other line is a header line. So that actually means 100,000 sequences. And I'll show you another command that we could use to find that out directly, which is grep. And grep will search for a pattern in a file. So, so if I say grep and then this little greater than symbol, that's, and I say the name of the file, that's going to spit out every single line in the file that has that character in it. So that's going to be a lot of output, 100,000 lines of output. But I could pipe that into word count -L, and now it'll simply tell me how many lines, how many sequence headers there are in the file. So that tells me how many sequences are in the file. There's another little shortcut. If you just want to count the number of lines with a certain pattern, you can use grep-c. That'll be faster, and it'll give you the same answer. So those are some of the basic commands that we'll be using in the class in Unix. If you want to learn more, here is a great online reference for that will teach you all about Unix.